Hi, my name is Abby.
And I'm Chloe.
And we're here today to learn about chemical reactions. Did you know that chemistry is useful in our everyday lives?
Chemical reactions such as photosynthesis, aerobic cellular respiration, combustion, and digestion occurred commonly and daily.
Chemical reactions are when one or more reactions change into one or more products.
Chemical reactions occur because atoms are trying to get a full outer shell of electrons. The total number of atoms is the same before and after a reaction. When an atom reacts with another atom to form a chemical bond, it will either lose electrons to form a stable positive ion, gain electrons to form a stable negative ion, or share electrons to form a stable molecule. To write a word equation, write the names of the reactants to the left of the arrow, separated by plus signs. Write the names of the products to the right of the arrow, also separated by plus signs. A lot of people wonder why chemical equations are necessary and why so many chemists use them. And chemical equations are used because they easily show an element or compound involved in the chemical reaction that you're dealing with. And it helps to show the reactants and products so that you know exactly what is happening as you watch it.
Although word equations adequately describe chemical reactions, it is easier to use formulas for the reactants and the products. This is called a chemical equation.
An example of a chemical equation would be silver sulfide plus aluminum yields aluminum sulfide and silver.
For our experiment, we will be using this exact chemical equation.
For our experiment, we'll be removing the tarnish off a silver spoon, which is actually a chemical reaction.
First, we will be taking this baking soda and we will be pouring it in extremely hot water.
Then we'll add the aluminum foil and place the spoon so that it's touching it in the water. Mix it up.
Guys, wait. Then you will mix it a little so that the baking soda will disintegrate. The reaction between silver sulfide and aluminum takes place when the two are in contact while they are immersed in baking soda solution. The reaction is faster when the solution is warm. The solution carries the sulfur from the silver to the aluminum. The aluminum sulfide may adhere to the aluminum foil, or it may form tiny, pale yellow flakes on.
We're going to explain to you the 5 types of chemical reactions.
The 5 different types of chemical reactions are combustion, single replacement, double replacement, combination, and decomposition.
Combination reactions are a reaction between 2 or more reactants to form one product.
Decomposition reactions are a chemical change in which one single compound breaks down into 2 or more similar products.
Lastly, a combustion reaction is a chemical change in which an element or a compound reacts with oxygen and produces energy in the form of heat or light. For a combustion reaction to take place, there must be oxygen as a reactant. Other common reactants are hydrocarbon, which is composed of hydrogen and carbon. A single replacement reaction is a chemical change in which one element replaces a second element in a compound. The chemical reaction that occurred in our experiment is classified as a single replacement reaction where the silver and aluminum switch places. A double replacement reaction is a chemical change involving an exchange of positive ions between 2 compounds. Double replacement reactions are also called double displacement reactions. They generally take place in a liquid solution and often produce a precipitate, a gas, or a molecular compound such as water. In our reaction, aluminum was able to replace silver due to the activity series chart. It lists metals in order of decreasing reactivity. A reactive metal will replace any metal listed below it in the activity series. Another important topic that we have to talk about when dealing with chemical reactions is the law of conservation of mass, which states that mass cannot be created or destroyed during a chemical reaction, which basically means that during a chemical reaction, if you start out with a certain amount of atoms, you're going to end up with the same amount of atoms. They might not be in the same form, but they're going to exist because they can't be destroyed within that reaction, and vice versa. So if you start out with 3 atoms in a chemical equation, you won't end up with 4 or 5 or 6 because you cannot create matter either. Some people ask where this chemical potential energy is stored. The energy that results during a chemical reaction is called chemical energy. It is a type of potential energy and is stored within the bonds of atoms and molecules that make up the substance. Once chemical energy is released from a substance, it is transformed into a new substance. So although you might not always see chemical reactions taking place around you, they do occur and very commonly.
From combustion to combination to single replacement to double replacement to decomposition.
Chemistry is everywhere.